Good day everyone! Today we will be exploring the Newton's three laws of motion through hands-on experiments and to gain a deeper understanding on how an object moves and interact with forces.
Newton's three laws of motions are fundamental principles in physics that describe how objects move and respond to forces. Isaac Newton is one of the most famous scientists to have great discoveries that explain how things happen through scientific experimentation and experience. So buckle up and get ready to learn about the laws that make our universe tick.
Get ready to uncover the secret of motions as we conduct a series of experiments bringing Newton's three laws to life, demonstrating the power of inertia, the relationship of forces and accelerations, and the balance of action and reaction forces.
The law of inertia, or Newton's first law of motion, states that an object will remain at rest or continue in motion with constant velocity unless acted upon by a net unbalanced force.
For this experiment, we need card and coins to show the law of inertia.
In this experiment, the external force from the card causes one coin to move while the other remain at rest due to their inertia. Throwing a stationary coin will stay at rest when the card underneath is wiped away quickly. The coin inertia resists the change in motion. The law of acceleration, more formally known as Newton's second law of motion, states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass.
For this experiment, we need a ball and a leaf to show the law of acceleration.
Showing a ball and a leaf dropped together will accelerate at the same rate due to gravity. This is because the gravitational force accelerates all objects equally, regardless of their mass according to Newton's second law. And in the absence of air resistance, there is no other force to alter their acceleration. The leaf causes it to be slowed down by air resistance, causing it to fall slower than the ball. The law of action and reaction, known as Newton's third law of motion, states that for every action or force, there is an equal and opposite reaction.
For these experiments, we just only need rope and two persons to show the law of action and reaction.
When two people pull a rope in the opposite direction, each person exerts a force on the rope. It is called the action. And the rope exerts an equal and opposite force back on each person. It is called the reaction. According to Newton's third law, the forces are always equal in magnitude and opposite in direction. The force applied by each person affects the motion of the rope. Each person pull is met with an equal and opposite force from the other person.